Guys, and welcome. We are, remember, doing Python programming, and yesterday we were looking at some simple top-down programs, and basically you would remember that all of our programs, when it executes, it goes line by line from the top to the bottom. So we looked at some very simple examples yesterday. So today we are going to be doing two things. Firstly, we're going to be looking at a simple top-down program. We're going to be looking at one or two of those, and then I'm going to be introducing conditional statements. Now, remember I told you that at the beginning that as a human being, we make decisions. The computer can also make decisions based on the data that it actually receives. So looking at our first question, and we're going to be using some of our built-in functions that we did yesterday and the day before. If we look at the question that is given, buses are required to transport pupils on an excursion. So each bus can only seat 35 learners. The question is this now: read in the number of learners that need to be transported and determine and output the number of buses that will be required. Right. So basically, if we have 35 learners, we would need one bus. How do we actually get that? How do we actually get one bus, right? Just going to run this so we can do some calculations. Right. So if you look at this, right, if we have 35 learners, we actually divide it by the number of learners that it can take, its capacity, which would be 1, right? If we had 70 learners, we divide it by how many learners each bus can take, and that would be 2. If I had 100 learners, and if I divide that by 35, I'm going to get 2.8. Right? You'll see what I'm talking about just now. If I had 90 learners, I'll divide that by 35, and I'm going to get 2.5. And if I had 80 learners, you divide it by how many learners the bus can actually seat, and you're going to end up with 2.2. But you must understand that we are talking about the number of buses. Now, we do not get 2.8 buses or 2.5 buses or 2.2 buses, right? We actually need to look at how we going to answer this question, because remember, the number of buses must be a whole number. There are certain things in the real world that actually deal with whole numbers. We call them ordinal values. For example, if we were looking at the number of people that attended a particular function, we're not going to say 3.5 people attended the function. No. Right? So the number of people, the number of animals, the number of chairs required, right? Chairs, we're not going to get 2.5 chairs or 2.3 chairs, etc. So we're going to be using one of our predefined built-in methods to actually work with this. So firstly, we looking at our input and casting. So remember, we can do two things over here. So let's analyze the question and determine what needs to be input. What tells us what our input is? The phrase read in. What are you reading in? The number of learners. So how many values are you actually reading in? You're reading in a single value. So let's go call our variable. Now remember, when a user enters values, we need a variable to store that value. So our variable is going to be called numLearners is assigned. Now remember, numLearners, is it going to be an int or float? You are not going to get 2.7 learners. You'll get 2 or 3 or 5 or 10. These are whole numbers. So we're going to cast it as an integer. And we use our input statement to give the user a friendly message asking them to enter the number of learners to be transported. Okay, once again, input reads everything in as a string. Int will convert it into an integer, sorry, and it's going to store it in num learners. So that's our input. Now, each bus can only seat 35 learners. So looking at our processing, right, we need the number of buses. So num buses is assigned, and we're going to take num learners and we're going to divide it by 35. So that would basically give us the number of buses. It's not actually correct. You'll see why just now. And we need to give the user some feedback, which is our output, and our output statement is print, which is basically the number of buses required is, and remember once again, you can only join a string to a string. So we have to cast num buses, which is our calculated value, as a string. So we're going to go with str num buses. Right, so just remember once again that all our variables need to be meaningful. That means just by looking at the name of the variable, we have a very good idea as to what data it's actually storing and what it actually represents. So let's go and run it. Okay. Now, remember that this is a real world example. For example, if your school is actually having an excursion, then you're going to need to know how many buses are actually particularly required, etc. So a program like this could actually help. So enter the number of learners to be transported, and we are going to say 75. And it tells us that the number of buses required is 2.1. Now we do not get 2.1 buses. And we certainly can't use 2 buses because there's more than 70 learners. So that means we're actually going to need a third bus. So just running this again, just so you can see, right? If I said we had 112 learners, we're going to need 3.2 buses. Now, remember, it can't be 2.1 buses. It must be the next whole number, which is 3 buses. It can't be 3.2. It must be the next, which is 4. And we have a function that we actually use for that. And what exactly is that predefined built-in function? We're going to go with num buses is assigned, and what is it? Now, remember, I need to use a math function. So at the top, we have import math. And we're going to come here and math dot seal. Remember that? That's just sealing. And we're going to come in here, num buses. All right. So let's run it once more. And if I have to enter 75. Now remember in our previous example, what did it give us? It gave us 2.1, but because I'm using math.ceil, it's going to give us 3. Get it? So if we run it one more time, And if I go and enter 75, previously it gave us 3.2, but right now it's giving us 3. All right. So okay, and that is actually, oh, I was supposed to actually enter 112. Sorry about that. Let's go run it again. And I'm going to go with 112. And you'll notice that the 3.2 became 4. So you will realize that when we are dealing with numbers of people and items and objects that you cannot get part of, right? You would actually use seal or floor depending on what is required, right? Now, if you look at the real world and some of the things that you cannot get fractions of, like I said, chairs, tables, people, animals, cars, buses, etc. All right, so books, you're not going to get 2.3 books, right? So that, remember, like I said, top-down programming. So it actually did that first, then it executed that, then it executed that, and the last statement. So basically it went from top down. Okay, now, similar type of question, still top-down programming before we actually start with the if, well, your conditional statements. This is a nice question. Like I said, it's a real world problem. And remember, when we are writing programs, we actually writing programs to solve real world programs. So for example, real world problems. So for example, if I actually asked you, if I told you, listen, here's the length and breadth of a room, I need to tile it, calculate how much it's going to cost for me to tile it, you can actually work it out. So every program that we write, we would ask ourselves, okay, how would I go about solving that problem? And I will basically simplify the instructions and give it to the computer as the computer program, and it would work it out for me. Remember, like I told you previously, a computer cannot make mistakes. So if there's any errors, it was because of the person programming it. So let's look at this question. Read in the length and breadth of a room. Okay, so read in means input, yeah? So read in the length and breadth of a room, as well as, that means in addition to the length and the breadth, you're going to be reading in, right? As well as the cost per square meter. That means how much does it cost to tile this room per square meter? All right. So let's look at it. I'm just going to run this so we can just look at some calculations and see how it would work it out. So let's assume the room was 3 by 4 meters. To find the area of the room, to find the area of any room, any rectangular room, or even a square room, it's going to be the length times the breadth. So 3 meters by 4 meters, and it's going to be 12 square meters. So it costs, the area of the room is 12 square meters. Then I'm going to tell you, you know what, it's going to cost 45 Rand 52 per square meter. 45 Rand 52 per square meter. So for 1 square meter, it'll cost 45.52. For 2 square meters, I'll multiply this by 2. I'll multiply this by 2, and it'll cost 91 Rand and 4 cents for 2 square meters. But how many square meters do I want to tile? I want to tile 12, so I'm going to multiply that. Now, this is me working out how I would work it out. So what did I do? I took the length and breadth and I multiplied them to get the area. And how did I get the total cost? I took the total area that I calculated and multiplied it by the cost. Okay, so let's go and look at how we would solve this problem. So firstly, like I said, we need to read in three things. We need to input the length, the breadth, and the cost per square meter, right? So this is going to be input and casting. Now just remember that the length and breadth of a room will not necessarily be a whole number. You're not going to get a room that is 3 meters by 4 meters or whatever it is. It might be 3.2 meters or 3.1 meters. So when we are inputting our length and breadth, it's going to be of type float. And if we are looking at our cost per square meter, it deals with money, and money is of type float. So firstly, we are going to read in, we're going to cast first, then use the input to enter the length of the room. Okay, then I'm going to go with breadth. Like I said, meaningful, right? And once again, input, single, and enter the breadth of the room. And one more, we need to enter the cost. Now I can go and call it cost per square meter. I'm just going to call it cost, right? Is assigned. Once again, it's float and input. And we're going to go with enter the cost per square meter. So that's our input and our casting. So we had three inputs: length, the breadth, and the cost. Now, let's go look at what processing we need. Now, here's the thing. Remember I told you that to determine exactly what processing we're going to need, we need to ask ourselves, what must we do with the input to actually get the output? So my output, I need two outputs. Firstly, I need to work out the area and then the total cost. And here we go. Total cost is equal to, or is assigned, the area times the cost per square meter. And how do you work out area? Length times breadth. So firstly, let's go and work out the area. The area would equal to length times breadth. And then I need total cost. So we're going to go with total cost is assigned. Now remember, it's the cost per square meter times the area that we calculated. Okay, so there's our calculations, and we come to the final part of the solution, which is basically displaying, giving feedback to the user with regards to what the area is and what's the total cost going to be. So we're going to go with print, and like I said, as user friendly as possible, the area of the room is, and remember, area is of type float, right? So we're going to go cast it as a string, and like I said, as user friendly as possible, square meters. we are going to come back to our output statements, well, actually our processing statements just now to show you exactly how to make it as neat as possible. And then obviously we've got print the total cost is, and that's going to be str, and that's going to be total cost. Now, let's see what it actually looks like. So I'm going to enter 3.4 meters by 5.7 meters, and the cost is 42 Rand 53, and we have given the program the three values it requires, and our answer doesn't really look very, very nice. Okay. So obviously the area of the room is 19.38 square meters, but just remember that you're not going to get 0.38 square meters of tiles. You can only buy them in square meters itself. So what must we do to the area? Firstly, we're going to come back here and looking at the area is assigned. And once again, I'm going to be using a math function. So we need our import math. And I'm going to come here and say math dot ceil area. So we moving it up. And then our total cost must be to 2 decimal places. Remember that? So how do we do that? So we're going to go with total cost is assigned. Remember our round built-in function, people? And it's going to be total cost, comma, it's money, so it's 2 decimal places. All right, and here I'm going to go put in an R just to make it look neat. So once again, I'm going to enter the same values, 3.4 meters by 5.7 meters and 42 Rand 53, and there we go. It moves the 19.38 to 20 square meters because that's the amount of tiles we're going to need. And you'll notice that it becomes 850.6. It's actually 60. All right. It just dropped the 0 because it's insignificant. It's the least significant value. All right. So looking at that there, like I said, it is top down, going from the top, coming down. And you'll find that there are a lot of programs that we can actually, a lot of things that we can actually do with programming to solve a lot of problems. All right, moving on. Now we come to something that's extremely exciting, and this is basically conditions. Now, what exactly do we mean by conditions? In programming, we will use conditions to determine whether something should take place or not. Remember in the first examples, in the first lesson, we looked at if I am hungry, then I will eat. So the condition is in this example is whether I am hungry or not. Secondly, if it is cold, then I will wear a coat. And the condition in this example is whether it is cold or not. So the first thing we need to master is how to evaluate conditions. Now, when a condition is evaluated, it evaluates as either one of 2 values. It's either true or it's either false. So what exactly do I mean by that? Let me show you, right? And we are going to come back to this. Okay, now remember in Python, we've got the plus, the minus, the multiplication, float division, integer division, and mod, right? So let's go and try something out here. We'll come to this question just now. Okay. So I'm actually going to do this. I'm going to say print 5 greater than 3. Can you see that there? So basically what exactly happened here? Python actually looked at 5 and it looked at 3 and it basically asked the question, is this 5 greater than 3? Yes, it's true. That's why it displayed true. If I went and put is 5 greater than 31, guys, it's going to be false. So whenever you evaluate a condition, just now I told you it will either evaluate as true or false. Okay. Remember the data types we looked at? We looked at float, we looked at int, we looked at string str, and we also looked at a data type called bool, remember? And that is exactly what this data type is. True or false is bool. So coming back here, instead of doing that, let's do this. If I said, I'm just going to use n is assigned 12 less than 89. And instead of doing that, I'm going to put n. Let's see what happens now. It's outputting true. Now, what exactly happened here? It evaluated this expression. Python evaluated the expression and asked the question, is 12 less than 89? Yes, it's true. So n stored the value true. That means, in other words, n is of type Boolean. All right, so let's come back here. Now, remember, we have arithmetic operators, but we also have logical operators. And logical operators, firstly, comparison operators, right? What do they mean? So firstly, the symbol greater than, it reads as greater than, and it will give you a true value if the left-hand side, the value on the left is larger than the value on the right. Example, is 5 greater than 3? It's true. Is 3 greater than 5? It's false. If you look at this symbol, it's less than, right? So basically it will give you a true if the value on the left is less than, is smaller than the value on the right. So let's look at this. Example, 3 less than 5. Is 3 less than 5? True. Is 5 less than 3? False. Now, remember we use the equal to assign values to a variable. So when we want to check if two values are equal to each other, we use a double equal. So it's equal, equal. And this will return true if both sides, the value on the left is equal to the value on the right. So is 4 equal to 4? We're looking at that. Is 4 equal to 4? That is true. Is 4 equal to 5? That is false. And then like in mathematics, we get does not equal to. You don't actually get that symbol on your keyboard. So we use a combination of these two. And the exclamation mark reads as not. And then we have equal to. So it's simply not equal to. It will return true if the value on the left is not equal to the value on the right. So 3, this is how this reads, guys. 3 does not equal to 5, and that is true. Look at the next example. 3 does not equal to 3. That is false. And then obviously we have a combination of greater than or equal to. So if the value on the left is either greater than or it is equal to one of those two things, then it will return true. So if you look at this example, is 5 either greater than or equal to 3? Yes, it is greater than. As long as one of them is true, it's going to give you true. Let's look at the next one. Is 5 either greater than or equal to, or means one of? If one of them is correct, if one of them is true, then it will return true. So we've got, is 5 greater than 5? No. Is 5 equal to 5? Yes. So it will return true. And then we look at the a false. Is 3 greater than 5? No. Is 3 equal to 5? No. So both are false. So it will give you false. And then obviously we have the opposite of greater than equal to, and that is less than equal to. So if the value on the left is either less than or equal to the value on the right, it will give you true. So let's look at this. Ask yourself this question. Is 3 less than 5? Yes. As long as one of them is true, it's going to give you a true. Look at the next one. Is 3 less than 3? No. Is 3 equal to 3? Yes. So as long as one of these two is true, it's going to give you true. And then lastly, we look at, is 5 less than 3? No. Is 5 equal to 3? No. So both are not correct. Both are false. It's going to give you false. All right. Now, very quickly, let's look at how we would go about doing something like this. And this is actually going through it. So we're looking at comparisons and we can see how they actually work. So remember, when you are evaluating a condition, whenever you are evaluating a condition, you are comparing the left to the right with regards to the comparison symbol in between. So in order to actually determine this, we're going to work this out. Tell me, 25//5. What type of division is that? That is integer division. So what's 25 divided by 5? Your answer is 5. And then we're coming over here. Is 5 equal to, and now we have 45 mod 8. What does the mod do? It divides and it will give you the remainder. So how many times can 8 go into 45? 8 can go into 45 5 times, and your remainder is 5. So 5. So this actually evaluates as true. You get it? So in other words, you could actually go and put a question mark here. You're actually asking a question, is this equal to that? And your answer is true. Let's look at the next one. Now remember BODMAS rule. So when you have mod and multiplication, we can actually go and work out the mod first. All right, so 10 mod 8. That means if I divide 10 by 8, what will be left? What's my remainder? So 8 can go into 10 once, and what's left over? If I take away 8 from 10, I'm left with 2. And then obviously I've got the times 12 mod 6. 12 mod 6. Now remember, you're getting a remainder here, guys. So 6 can go into 12 2 times, and your remainder is 0. And we are checking if it does not equal to 0. So once more, evaluation, guys. What is 2 times 0? 2 times 0 is 0. And the question we're asking is, 0 does not equal to 0. Right? Like I said, question mark, you're asking a question. Okay? 0 does not equal to 0. True or false? That is false, because 0 is equal to 0, right? So how do we actually go about using conditions in programming, remember conditions are used for decision making. So based on whether a condition is true or false, your program will either do this or that. So the first thing we're going to look at is our decision making statement is called an if else statement. That, what does that actually mean? It means, firstly, we use the if, just the if on its own. And the format is very simple. If your condition and then colon, right? Then these three statements, you'll notice that they are slightly in underneath the if, right? They will all fall, that these will all take place if that is true. This statement is in line with the if. That means it's outside of the if statement. And that means whether the condition is true or false, this statement that I've highlighted will always take place. The statements over here that are slightly in, that's called the body of your if statement. Okay, so just to show you how that actually works, right? I'm going to come over here and I'm basically going to say if, sorry about that, right? If 5 greater than equal to 3, colon. Remember that you need a colon. The colon means then do the following. The colon reads as then. If 5 is greater than equal to 3, then, and watch when I press the enter, the cursor is here. It's not in line with the if. So I'm going to do a few things over here. I'm going to come here and say print 1, and still inside the if statement, print 2 and print 3. Oh, should have spelled that. Right, now watch what I'm going to do. I'm now notice my cursor is in line with the if, and I'm going to or false, I will always execute. Check it out. So what's my condition? This is my condition. So before we run the program, let's look at it, right? Is 5 greater than 3? Yes, it's true. So it's definitely going to do this, and it will definitely come and do this. So let's go and check it out. Check it out. 5 was greater than 3, so it output 1, output 2, output 3, and this last one, whether the condition is true or false, I will always execute, also executed. Now, just to show you something else now, I'm asking you, is 5 greater than 31? No. Is 5 equal to 31? No. So none of this should take place, but that would always take place. So let's go check it out. Notice what your output is. Whether the condition is true or false, I will also execute. I will always execute. So can you see the 1, 2, and 3 were not displayed because the condition was false. Okay. Now I've actually put in 5 and 31 here. All right. I'm actually going to take all of this out. And let's answer this question. So this question basically says, read in two integer values and determine an output, the larger of the two values. I'm going to show you a few ways of actually doing this, right? remember, as far as possible, I want to have one print statement, but I'm going to show you the different ways you can actually do this. So for input, remember, and it's going to be input and casting. Okay, so I'm going to go with num1 is assigned int, I'm casting. Input, I'm asking the user to enter, and I'm going to say enter first value. Okay, and then I'm going to have num2 is assigned int, input, enter second value. Okay, so the user is going to enter the first value and the second value. Then this will actually be our processing and output, right? Because we're not, and you'll see I'm going to separate it just now, and output. So what is my condition going to be? The user is going to enter two numbers. The first number is in num1 and the second number is in num2. The question is reading the two integer values. Yes, we input the two integer values, and we're going to determine an output, the larger. So what is basically my condition? I'm going to compare num1 to num2. And I need to check which one is larger. So which symbol am I going to use? I am going to use the greater than. So if num1 is greater than num2, remember colon. Now, if num1 is greater than num2, that means that num1 is the larger value. So I'm going to come here and say print the larger value is, remember, typecast, and I'm going to output num1 because num1, if that is true, then num1 is the larger value. Okay. Then I'm checking one now. I'm checking if num1 is greater than num2. What's the other condition? The other condition is, what if num2 is greater than num1? So if num2 is greater than num1, colon, remember, and I'm going to output what? I'm going to output the larger value is, and remember typecasting, and I'm going to output num2 because num2 is the larger value. All right, so the user enters two values and we're comparing, we're checking if the first value is greater than the second value, and if that is true, then I'll display the first value. If the second value is larger than the first value, then I'll output the second value. So remember, we have to take all possibilities into account. All right, so if I run this, and I'm going to run it twice, I'm just going to close that. Okay. Okay, let's enter two values. I'm going to enter 12 and 6. So the first value is larger. That's num1, guys, right? So what is it going to output? What should it output? Is 12 greater than 6? Yes. So the larger value is 12. And if I go and run it one more time, and if I enter 65, my first value, and 98, it should output 98. So if you look at this, guys, in this part here, for this example here, this statement was true and it displayed num1. In the second one, this statement was true, so it displayed num2. Now, I told you that we have two print statements that we can actually just use one print statement, guys. And in order to actually do that, right, I'm just going to show you something. I'm just going to take that out from there, and you'll see why just now, and I'm going to paste it there. I'm going to introduce a third variable, and I'm going to call it larger. So, sorry, I'm just going to click here and press enter. I'm going to introduce a new variable, larger is assigned num1. Now, what am I doing? If num1 is larger than num2, then I'll take num1 and put it in larger. And if I come here, if num2 is greater than num1, then what do I do? I'm going to say larger is assigned num2. So after these two if statements have been processed, depending on whichever one was true, larger, the variable larger stores the larger value. So I don't need two print statements. All I do is the variable larger stores the larger value. I come and just display the variable larger. So, all right. Okay. Now, what is the problem? You see, it's not at the end. It was indented and it saw that as an error. Okay, once again, I'm going to go and enter 12. Okay. Run it again. Why is it? No, it's running something else. Okay. Enter the first value, 12. Enter the second value, 6. And it's going to output that. Now, this is the program that's running. And remember, larger, 12 was stored in larger. Do you follow? You'll notice that. Okay, let me show you one more time. We're going to enter our other two values. I'm going to enter 60 and 98, and it's going to output 98, which is basically that there. I did want to point out to you that when we convert everything and display, you'll notice that it's all blue. That means those are strings. All right? Okay, so simple program to check which is the larger value. Now we can use the conditions for lots of very, very useful programs. And let's look for another one. So we looked at the larger, positive, negative, or 0. Okay, this is a nice question. Read in an integer value and determine an output whether the integer is positive, and positive is greater than 0, or negative, which is less than 0, or it's neutral, which is equal to 0. So I need to check three things, yes or no. And once again, I'm going to have three if statements. So I'm going to go with input and casting. And I'm going to go with num. I'm just going to call it num is assigned int input, enter an integer value. Right, so the user is going to enter an integer value as a string. Int will make it a number and store it in num. Now, I'm going to need to check three things. Firstly, I'm going to check to see if num is positive. Secondly, if num is negative. And thirdly, if num is neutral. Now, I can have three print statements. Remember that, right? So this is what I can do. I'm going to go with if, oh, sorry about that. This is going to be our processing and the output, but I'm going to show you how the output will change. So basically it's going to be if num for a positive number greater than 0, colon, then I'm going to come here and say print str. Check this out. I made it a string plus is, now if it's greater than 0, it is positive. Okay, then I'm going to come here and I'm going to check the other one. If num is, what's my second condition? If it is less than 0, then don't forget the colon, print str num plus is negative. Okay. All right. And then one more, if num equals 0, then print str num plus is neutral. That means if it's equal to 0, it's neutral. Doesn't look very difficult, does it? So let's run it and check it out. If I enter 5, it's positive. Run it one more time. If I enter -8, it's negative. And lastly, if I enter 0, and 0 is neutral, can you see that? But like I said, as far as possible, we want to have one print statement. So instead of having 3 print statements, you see each of these statements here, guys? And I'm going to take that out, and let's create a new variable called message is assigned. So that means I'll take this message and store it in that variable. Do you follow? So I'm just going to copy that out and do that. Can you see that? And do that. Paste it there. I could have typed it out. It would just take longer. So if num is greater than 0, message will store the number is positive. If num is less than 0, message will store the number is negative. And if num is equal to 0, message will store it's neutral. And then I just put a single print statement. And where's my output actually stored? It's stored in message. So just going to output message. And once again, if I run it, if I'm going to enter 7, there we go. 7 is positive. If I run it again, and if I enter -2, it's going to be negative. And if I run it one more time and enter 0, it's going to be neutral. So you will notice that this works just as well. The good thing is that there's just one print statement. Okay? So if we look at now, this is simple, greater than, less than, equal to, etc. Now, one of the things that we normally ask to determine, right, is there. Reading a year in the format YYY, what does that actually mean? This means you're reading it in as 4 digits. So you're not going to enter 21, you'll enter 2021. Now, why would we need to determine whether it is a leap year or not? Because generally in a leap year, we actually have the Olympic Games. So the question would be, hey, reading a year and determine whether the Olympic Games are actually going to take place or not. So what exactly is a leap year? A leap year is any year that's divisible by 4. Now, if any number can be divided by 4, the remainder would be 0. What am I talking about? Here, if I told you 16 divided by 4, it's going to give me 4. But if I wanted the remainder, what do I use? 16 mod 4. And can 16 be divided by 4? Yes. Remainder is 0. If I took the number 20 and if I used mod 4, can 20 be divided by 4? Yes. So the remainder will be 0. So any number that can be divided by 4 will give you a remainder of 0. So we need to determine the remainder. We need to determine the remainder. So we're going to read in our year and then get the remainder. And if the remainder is 0, it means it's a leap year. So let's check it out. Right? So we're going to go with input and input and casting. Okay. Okay. So I'm going to go with year is assigned int input, and we're going to ask the user enter the year using 4 digits. Okay, then we have our processing, and now I need to determine the remainder, guys. So I'm going to use a variable called rem. No. Okay, yeah, let's use rem. Rem means remainder is assigned whatever our year is, mod 4. So what exactly will happen here? It will divide year by 4 and it will take the remainder and put it there. And remember, if the remainder is 0, it means that that year is a leap year. So that brings us to our condition. If rem equals 0, then message is assigned it is a leap year. All right. And if it does not equal to 0, then my message would simply be it is not a leap year. And like I did in the previous programs, guys, like I did in the previous programs, one print statement, and my output is going to be in the variable message. So I'm going to go with running it. And let's enter the year 1990. It's not a leap year because it's not divisible by 4. If I go and enter 1996, it is a leap year because it's divisible by 4, right? So if you look at it, our solution, this is the important thing. We are determining the remainder. Well, hopefully we're going to meet again soon once the program, continues, but we're now last minute for today. So just going to show you something a little different, right? Okay, so can you see I'm saying here if rem equals 0? Instead of using rem, I could have just done this, guys. And take that out variable completely. Can you see that? I can do all of that in one line. I can do the calculation and compare. So run it one more time. And I'm going to enter 1990. It's not a leap year. And if I run it one more time, and if I go and enter 2020, it is a leap year. So you can do all of it in one. All right. So, right. So thank you so much, guys. I hope you guys have found the lessons useful. Just remember that all of the lessons are on YouTube and the previous workshops lessons as well, the courses lessons. Please go and check them out. Right. Take care. All the best. And remember, practice all the time because programming is one of those fascinating stuff. All right. Thank you. Take care and good afternoon.